Okay. Hello, everybody. My name is Stefan Lehmann, and this is live from Las Vegas, beautiful state of Nevada. Another sunny day, winter day. We are very lucky. We have a speaker from Chicago, which is Leung, director, principal at SOM in Chicago, very famous firm. And we look very much forward to hearing from Luke what he's going to talk about, what are the factors that will impact your careers. We have the cohort, the Master of Architecture students that will finish their studies in May 2023 shortly. So my great honor to introduce Luke. Luke is a lead fellow, ASHRAE fellow, ASHRAE director at large, Carbon Leadership Forum, founding member, and has all kind of other distinguished titles. And he's a lecturer also at ASHRAE, and he's a firm-wide principal and leader of sustainability engineering in the studio of Skidmore, Owings, and Merrill, which are active globally, as we know. And Luke, if you can turn on your camera, please, that we can welcome you. Thank you so much. Great to see you again, man. And very much looking forward to your lecture. And then later, so if your lecture is like 40, 50, 60 minutes around that, and there's no fixed frame around that, and then we can have some discussion. And students, please send in your questions in the chat, and also ask questions in the Q&A session after Luke's presentation. So, Luke Leung, over to you. And thank you again from UNLV School of Architecture that you can make it to be here.
Yep. So thank you for the invitation. For the students, I want to let you know that I'm here for you. So feel free to ask questions and stop me anytime if you have anything you're thinking on your mind. I do want to share with you a little bit about my firm before we dive into the discussion. As you can see in the screen here, this is our website. And SOM is really a collective of architects, engineers, designers, planners, and it's about the collaborative, the founding members of S, Skidmore, O, Owings, M, Merrill, is actually two architects and one engineer. So the DNA of the firm has been left brain, right brain since day one. As you can see in our work, oftentimes is a lot of big and tall buildings. And the tall buildings, especially traditionally, the structure of the building really got expressed into the form of the building. Especially tall building, you have to take care of the wind forces. So a lot of the tapering, a lot of the changes is because of wind. And we are interdisciplinary from the start, like we mentioned. Some of the buildings that you might have familiar, the John Hancock building in Chicago, the one on the left here, with the X-bracing, and some of the structural forms of the recent design. We've been always advocating for the environment. UC Merced, you're seeing on the left, is one of the net zero campus in US. Pearl River Tower on the right, taper the tower to take in the wind to generate wind power. And obviously it's a place for nurturing people. And there are two things that I really enjoy working in the firm. Number one, exceptional people. I'm always amazed by what these people are thinking when you start collaborating with them. And second thing is this projects and the whole firm really evolve around design. As we can see here, the left is a structural piece and the right is actually a robotic printing. Either one of them, they are both structural element, but also the structure is the form of the structure become part of the design. So this is a little bit of SOM, and we did different projects in the world. One of my projects in my lifetime that's interesting is the Burj Khalifa, the tallest building in the world. You might have seen our project in New York City. This is World Trade 1. So this is a little bit about my firm. I'm gonna stop sharing and I will go to, oh, first of all, let me take a pause here. Any question about SOM? Okay, hearing none. The next thing you may want to pay a little bit more attention. It is about your career, the next 30 years. So I'm gonna do a little thing here. I want to tell you a little bit about myself. Let me see. You probably see the presentation mode. So let's get out of there. I'm going to tell you a little bit about myself. And then I want to work with you to talk to you about 3 elements that's going to shape your career and change humanity forever. Let me tell you one thing. If you are a student graduating, you are born in a time, a very interesting time, that the future of humanity is rests in your generation's hand in many ways. So very critical part of humanity history. But I want to start talking with you about me. If you are Chinese like me, which I don't know any of you are. So when I was young, I was fascinated. One of the first few words I learned is mouth. I was fascinated at the simplicity of the Chinese. They saw a mouth, they said, ah, a mouth. And then they draw a mouth and then they call it the mouth. And then they also draw this is the word for grain. And they look at the grain and said, nah, it's kind of look like that. They draw the grain and it's a grain. I was surprised by the simplicity of the Chinese to use this picture to represent the words. Now, later on, I grow older. I took advanced Chinese. And then we start combining words. So you can combine the word mouth with the word grain. You know what word will you get? Peace. Wait, what? How did that come from? Well, let me put it this way for you. If tonight you're going to go to a Chinese restaurant, you want to eat and there's no rice, you think there will be peace in the restaurant? I thought the Chinese are pretty clever, right? No rice to eat, no peace. I thought that was what they meant. And then I grow older, I realized, no. What it meant is the mouth is representing humans. The grain is actually representing nature. And what they're trying to say is peace will not come until human and nature thriving side by side. I thought that was pretty intelligent of them. And then I went to Bursa, Turkey this year. So I saw a tree, I saw this tree. And I thought, what if buildings are like trees? Well, what do I mean by that? They capture carbon, they clean up the atmosphere, the earth, and the water. They recycle everything. And if you are like this tree here, it lasts for 600 years and provides this environment and shading with humans below. Well, you can expand that nature of a tree to a larger scale. I work in Chicago. Some of you know that Chicago's planning is really in the 1900s by a guy called Daniel Burnham. And the motto of him is make no small plans. Let me encourage you to do that in your career. Make no small plans. And it's because of Daniel Burnham, think big. Big as in master planning the entire city of Chicago. Today, the lake shore of Chicago is given back for the people, and it looks like this. So in summertime, there's this green belt along the most beautiful part of Chicago, the lakefront, and it's for the people. The buildings are set back. Unlike Manhattan and many parts of the world where the buildings go right up to the shore, the best part of the city belong to the people. And it's all because the vision of a person he decided to think big and work with nature to integrate with human. Not that much different than the Chinese word peace. So what are the 3 things I'm going to talk about to impact your career? You're going to be working on it probably for your whole career. The first one is carbon. The second one is human. The third piece is terrestrial. Okay, first talk about carbon. Now you know that by the year 2060, we're going to have 10.1 billion people. It's only like 38 years away, 40 years away. And we're going to need 2 times the amount of built area to accommodate these 10 billion people. So good for you, because plenty of work to do, right? But what's important is the difference between global north and global south. Much of the development is happening in India, China, Middle East, Africa. So who want to go to Africa to work in the near future? Part of the issue of the global south rather than the global north is global north, many of the countries already committed to a net zero world by 2050, carbon neutral by 2050. But the countries below the black line, many of them are not committed to yet to that 2050 carbon neutral. And the electricity grid is not so clean, as you can see here, the darker color, the China, the India, the Middle East, the Africa. So as they grow, it's very important that they don't go through that cycle of China, what they're going through now, or LA or London or these cities in global north, that they actually contaminate the air and the environment before they switch to clean fuel. Let's hope that's not going to happen. Because when you look at the timing, global north is all the countries in blue, 2050, carbon neutral, but global south, which is the color, there is no color, are the countries that are committed to beyond 2050. You can see India, Middle East, China, north of Africa, all those countries, they are not committed to net zero by carbon neutral by 2050. They committed to beyond 2050 to be carbon neutral. So the world as a whole, the year was 2015. At that time, humanity is 1.0 degrees C warmer than pre-industrial revolution. Now, at that time, there was some scary stuff going on. And you can see here, some projection is like 6+ degrees warmer than pre-industrial revolution, right? Not so good, it's scary. Fast forward to 2022, today, we are at 1.2 degrees C warmer. So 0.2 degrees C warmer. But most people now predict our future is a little better. It may be 2 to 3+ degrees warmer. Some of the most scary scenario, we don't think we're gonna get there. But we are not there yet. We are not there as in 1.5 degrees C. Guess which generation is gonna have to fix that? Yeah, that's right. You raise your hand, you're right. We are not there. It will be up to your team, the next generation, come and fix it before 2050. Now, when you fix it, pay attention to this chart here. There are 4 elements. If you want to get to net zero in a building level or city level, there are 4 elements you need to think about. The first one is something we are more familiar with, the operational energy. Now, this is a net zero school SOM did, the first one in New York City. The form of the building tell you what it is, right? Just tons of PV, right? And that's what it is. Tons of PV cladding the entire school and make it net zero. First, we make the building very passive, a lot of daylighting, very, very good insulation. And then we put tons of PV to get to net zero. That's low rise. What about this building here? 500-meter tall tower, not so easy to get to net zero. But we align the building, this is in Pertamina, 1 degree north, global south, 1 degree north of equator. So we align the building east-west, so it has only north and south facing because high angle sun, remember, right? Almost equator. You don't really have low angle sun on the north and south side, only east and west. So if we can align the building east and west, avoid the low angle sun, then we provide shading for the building, but we don't get there to net zero on site. Guess what we did to get to net zero? We dig deep, really, really deep, 2,500-meter deep, and get the deep geothermal heat to heat the building to make it net zero on site. So the point is, there are ways to we get the operational energy to zero, and we know a lot more. Now, it could be beyond building elements like density. In this case here, red is US and Canada, blue is Europe, the green is Asian countries. And then we plot density against CO2 emission, transportation and buildings, not just transportation and buildings. And what you find is it rapidly drops as you get denser in terms of total carbon emission for buildings and transportation, but it level off really quick. So that may be the density we want. We do not need like density as of in Manhattan or downtown Hong Kong, that extremely high density sort of city. Once you turn the corner around this density, maybe about 2,000 to 6,000 people per square kilometer, you can get denser, but you may not get too much. You cannot squeeze too much out of it anymore. And then your future could be very likely a little different in terms of transportation. Hold on 1 second. Oh, sorry. Let's do that again. Apologies for that. So sorry, I might need to do this. Okay, there you go. So in terms of transportation, you probably know by now that most likely it will be a demand base in the future. It's not going to be just buses running on the street. Most likely as a demand base, you use your iPhone to call the transportation come. This is the way we work in Chicago. We developed this idea for Chicago, which is a on-demand system with different sizes depending on what type of buses you need. And then it will come to you in different way. All these buses are generated by supported by renewable energy. So this is our transportation. Now, beyond building on the transportation side, there's some things happening around the world that you may want to know. This town we are planning in China, it will have 90% autonomous public transportation, only 10% private vehicle. Because of this on-demand public transportation system we are developing for them. So what about a city? Only 10% of the vehicle are private vehicle and 90% are autonomous, public, and electric. You think that may be far away, but this is in a city in China right now happening. And unlike US, outside of US, a lot of the transportation among different cities are actually on high-speed rail so that they don't have to take airplane. Think about you have a high-speed rail connecting all the East Coast city, right? So you don't have to fly every time you're from one city to the other. That's a lot of carbon. So the operational carbon on building side and transportation side, okay, that's one dimension. The second dimension of carbon is embodied carbon. So you might have heard something about it. Now, if you don't know this module, you better start knowing this, what they call A, B, and C module. A module is product to construction, right? Building of the building is A1 to A5. U stage is B1 to B7, B1 to B5, and then end of life is C1 to C4. Those together compose embodied carbon. You have a question? Somebody turn on the mic. Or just an accident? I would imagine just an accident then. So get familiar with this. This is composed of your embodied carbon. You may ask, wait, why is there a U stage embodied carbon? Now that means after you build a building, if your building need maintenance, right? For example, you have to fix the exterior wall. That is not operational carbon. That's embodied carbon that need repair, okay? So so like how do you reduce the embodied carbon? Well, obviously, if you use bio-based material and then minimum maintenance, the building can last longer. All those are ways to reduce embodied carbon. So I want to give you an example here. A lot of people say, well, embodied carbon is not important. It's really your operational carbon. This is a typical building running on a global average electricity grid. Earlier, you saw different countries has different electricity grid. Some are dirtier, some are cleaner. So this is the global average. In a global average city, the green is the operational energy, dominates it right now. Embodied carbon is the blue, is architecture and structure. Orange is MEP. Gray is the refrigerant. Not so significant in a global average building. But if you move to Spain, the electricity grid is cleaner. So the operational piece is not as important because the grid is cleaner. The embodied carbon piece is more important. Wait, what did we say earlier about the commitment of the Global North? By 2050, it will be carbon neutral. In US, the administration is saying by 2035, we will have a renewable energy grid. If that's the case, right? Let's say 2035, we'll have a clean electricity grid. The green piece you're looking at on the left become only 33%. The embodied carbon start dominate like right now because the grid is getting cleaned up by 2035. And if you are in Spain, which is on the right-hand side, your operational carbon from now till 2035 is only 15% of your total life cycle carbon. So the embodied carbon actually dominate if you live in an area with very clean electricity grid. What's the point? The point is you better start knowing embodied carbon, how to design them, because if the grid is going to get cleaned up by 2035, your focus right now is not just on operational energy. In fact, I would suggest your focus right now is actually more on the embodied carbon than the operational carbon if the grid gonna get cleaned up by 2035. So finally, the piece here now, so far I want to touch on what we talk about so far on the carbon side: operational carbon, embodied carbon, the comparison of the two. I'm going to touch on this piece here. It's not getting addressed in US, but it might be one of the major things you might encounter in your career. Is this last piece here, module D, is the circular economy. What you're looking at is City of London, not US, European city, London. What they are thinking of, how they gonna, remember, their electricity grid is clean, so they need to start focusing on embodied carbon. What did they say? This is what they said. On the left here, business as usual, 800, 1000, you see this number, those are the embodied carbon of a typical building. They said this is not so good. Oh, by the way, the unit is kilogram CO2 equivalent per square meter. So per square meter generate that much embodied carbon. So the 2020 target for the UK, city of the London, is 500 to 600 kilograms CO2 equivalent per square meter. What do they want is, in order to get there, the circular economy have to have 30% recycled material going into the building, and end of life, 50% of the material go back to recycling. How about the building you are designing? What percentage of material is actually coming from recycle? And have you think about the end of life? What do they do? Where did the material go? Is it like a tree? The tree I saw in Bursa, Turkey? Moving towards 2040, in order to get to a net zero world, what the UK consultant suggesting is, in order to get to zero embodied carbon, they want to see a building that is 100% recycled material going into it, and 100% end of life of the building is go back to recycle. Are we designing buildings like that? Could that be one of the challenge in your career? You know why? Because the first circular economy standard come out for lighting industry in UK already. Now we are bringing this standard into US, so we can start designing lighting fixture, designing our HVAC system, our partitions come from recycled material and goes back to recycled material. So that's carbon. Should we keep moving or take a pause here and take some question? What do you guys want to do?
Are there any questions at that point?
During the design process, is there like a consultant that you guys have internally or the external SOM, or is it like a internal research process when choosing kind of your materials and how you source them in regards to
Yes.
the stored carbon?
Remember, the first thing I mentioned is our DNA is arts and science together. I'm representing the screw up, like the screw up. My team is kind of like the screw up brains. We have the architects, we have the engineers, like we have no idea whether we are architects and engineers, and we basically do all the analysis for the whole firm. And you will see later some of the work we did, but that's a great question.
Okay.
And as you pick your career and pick the firm you work for, right? And they are all good, right? They're just different. Some are more pure design, about more the form, about more the shape. That's one way of doing design. And then some are more engineering. I will say SOM is very much form conscious, but very much also engineering conscious. So I think the idea is you could have the look of a super model, but then you can also have the guts of an iPad. I know it's kind of tough to think about all this can be put together, but think about a super beautiful being, but have the heart of Mother Teresa. That may be another better way. You can put those together if you can make no small plans, but that's our philosophy anyway. Any more questions before we want to keep going?
Looks like we can keep going. Thanks.
Okay. Humanity, let me suggest to you that you guys are in tough position in the next few decades against the human issue. Now, this is 1950, 2.6 billion people, but 7% of the people above 60 years old, 7% only. Pandemic hit them. Pandemic hit humanity many times. Never as bad as this one. Why? Well, 1960, only 7% of the people above 60 years old, right? So doesn't matter. It's like there are plenty of hospital for that 7% of people. Now you fast forward to today. Humanity grew. We grew to 7.8 billion 2020. But note the people about 60 years old become 13%, almost double. As a result, pandemic hit us now much tougher because of the older people need medical care. What happened to your generation when you get to about 60 years old? What do you think? Let's visit there. By that time, say another, I say, 40, 50 years from now, almost 30% of humanity will be about 60 years old, and we will have almost 10 billion people. When the pandemic hit us, when you are about 60 and you have 30% of the people about 60, not so good. Think about the decision they have to make to decide, well, which one's going to go to the hospital, because we cannot accommodate 30% of the world population in hospitals. So health is going to be phenomenally important in the next few decades because of the growth in humanity and the aging. Now, this is the physiology of human system. There are 10 different systems. I'm going to touch on 5 to think about the design component of it. Respiratory system, plenty of that discussion during COVID. When you are outdoor, there's a rule of 1,000. You are outdoor, you are 1,000 times less likely to breathe in anything released into the air. So that's why majority of the COVID happened indoor. So we start designing building like this. This is WeBank in China. Banking is just a walk in the park. Plenty of exterior space, shading against the hot sun, balconies, and also natural ventilation using the atrium to draw in the outside air as stack effect. And look, the trees around it to bring in a diverse of microbiome, which we'll touch on why that's important later. So this is WeBank, and you can, but this is sort of like your question earlier. We actually have our in-house engineering team to run this modeling, to understand how the airflow, natural ventilation. And in different corner of the building, we open the building to the outside, similar to this, and we run the simulation to see how the outside air will come into the building and create this exceptional environment for the indoor, outdoor to kind of blend together. So that's kind of briefing quickly. The nervous system about your brain, it has a lot to do with soft fascination. Wait, what did I just say? Soft fascination. The idea that nature can offer you fascination, but it doesn't make you tired. Now, there's another type of fascination called as hard soft fascination. When you look at an iPhone like that, it definitely fascinates you. You probably spend a lot more time than you should on it. But after a while, you get tired, unlike looking at nature, right? So soft fascination usually can increase your cognitive abilities. There's plenty of study before an exam. If you walk through a park, it will improve your retention ability. You remember things better. If you play with a lot of video games, chances are it will probably decreases your retention ability a little bit. So in this similar building, WeBank, we deliberately bring in the pattern of nature as in the wood and the trees, the round corners, to bring in the soft fascination to make you less tired in a visual environment. Muscular, you know that, 7,000 steps away, keep the doctors away. iPhone in-house all day, you're gonna have decrease in your vitamin D. So this building here, the new school in New York, it was deliberate to express that stairwell as part of that circulation walking space. Your hormones, the circadian rhythm. Do you know that there are more blood flow to your brain when you're sleeping than when you are awake? Now, let me tell you this, if you're guys or girls, your superpower comes from sleeping in all ways. Okay, think about that. There are many research talk about your life can be a lot stronger when you sleep better. including sexual life. And your growth hormones actually happen, as you can see in the, melatonin is your sleeping hormone. And then thyroid is how your body actually generates more hormones when you are sleeping than when you are awake. And your growth hormone actually happen at about 10, 11, 12 o'clock. So if you have a kids in the future, you want them to grow tall, get them to go to sleep early. Don't stay up all night and watch movie and all that, right? And college student, you probably, if you were like me, you probably stay up a lot, having fun maybe. But remember, your circadian rhythm in the long run is actually important, and rest is what makes you a superhuman, not when you are awake. It's the rest. So designing building with a circadian rhythm of lighting, of holistic day and night rhythm. So you probably heard about a lot about how lighting can impact your circadian rhythm. I'm not going to try to dive into it. The color of the light can impact you. Prefer orange, red in the evening, white and blue in the daytime, etc. So if you are like my daughter, which is in college right now as a freshman and has 1,300 followers, and she follows 1,200 people, you will probably have issue like this, and she does too. Vitamin D deficient, because all day long it's like iPhone indoor. So this is an issue worldwide right now, vitamin D deficient, especially African American and Hispanic people. So it is an equity issue too. So we designed building with a porch on the south side in Chicago to allow people not to get out of the building to get the sunlight, but inside the building, you can still get sunlight in the daytime. All you need is 15 to 20 minutes when the sun is above 50 degrees in altitude, then you will get the vitamin D forming in your skin. So guys, how about just 20 minutes, noontime, go outside? How about that? This may be something that you may not design to. Who has ever designed a building that designed for microbials? Anybody?
Hospitals?
Kill them. So yes, in hospital, we kill them. But microbial actually is composed of majority of your single cell on your or your the microbes on you are actually helping you, right? So, and a lot of those microbes are not made by you, but it's your environment survive on your body, but keeping you healthy. So this is a New York University study saying that in urban environment, the microbiome makeup is completely different than rural environment. But look at their conclusion. There are many chronic diseases in our generation. And moving forward with 10 billion people, can you imagine if significant amount of them have diabetes, obesity, and all kinds of allergy, asthma? It's not going to be a good place to be. The conclusion of this study in New York City is saying, we are seeing all this issue with chronic diseases because of the disturbances of the microbial biome in our environment, meaning that we screw up the environment, the microbial is not good. That's why we have chronic diseases. So what did we screw up? Well, pre-industrial days, we have a very circular kind of flow of waste and back to the plant, to the human. But we cut it off today, right? We have pesticides, all kinds of things, cut off those microbial circulation. So our food, our environment is very sterile. First you think, oh, sterile things should be good, right? Well, you know what? Like your body needs physical exercise, your immune system needs physical exercise too. If you cut off the immune system with a very sterile environment, the moment they got any microbials attacking them, they have no idea what to do. We need to train them. We need that microbial. How do we know that? What if we push back in time? Obviously, nobody can go back to the time tunnel, but we can look at the Amish people, right? Where I live, plenty of them around us. you will find out the Amish people, their gut microbe is completely different than the typical Americans because of their diet, close to nature, time outdoor, significantly different gut microbe. Why is the gut microbe important? Now, if you add up all the gut microbe in your tummy right now, my tummy too, it's no more than the size of a mango, but it impacts your immune system, it digests the food for you, your brain development, and it eliminates pathogen. You are what your gut microbe is. Because if your gut microbe cannot digest certain things, it won't be part of you. So they find out the gut microbe, actually, this is an Oxford study, I believe. It will impact your asthma, it will impact cardiovascular disease, diabetes, all these crazy chronic diseases. In fact, this study from Johns Hopkins University, they said, well, if that's the case, what if we transplant some of these gut microbes from a healthy person or a Amish person to a typical American? They find out they can cure certain diseases up to 90% because of the gut microbe of a person transplant to another person. This is the study from Oxford University. It said the gut microbes, because it digests food and impact your brain, it actually impact your personality. So next time, if you get on to a casino, since you guys are in Las Vegas, I mean, the guy personality is really weird. Well, you don't know what's inside his gut or her gut. The gut microbes have something to do with it. Check out what he is. Another paper here talk about the soil contribute to the human gut microbe. It was essential evolution of the human gut microbe. This is saying, the food we eat is from the soil, from the farm. So if the farm screw up, the soil screw up, well, then you screw up, right? If the farm is fed by nitrogen, well, guess where the nitrogen is going? So what happened to the terrestrial? This is a final piece, and it's a very fast piece, and we'll go through, but it's probably the most important piece here. So terrestrial, you mentioned earlier, what do our team do? Well, this is what we do. We actually, in this case, our project is the Earth. We study the Earth to figure out a way to feed 10 billion people and figure out the issue of the world. This is about 8,000 BC, where the world looks like solid green, temperate forest, grassland, lighter green, right? Well, guess what happened today? Are you ready? Well, this is what happened today. 8,000 BC today. First thought is, wow, man, civilization really conquered all those areas, right? No, all those are just farmlands feeding us. Remember the gut microbe issue? We left all the trees and create farms, rangelands, and that's what happened. The urban environment, only a very, very small portion of the pink and the purple. So you will have to deal with this in the future. Environmental product declaration. Each product can tell you what's the impact to the environment. What are the things you want to think about? The first one is ozone depletion. There was a time, there was a hole in the North Pole. It's the thinning of the ozone. But from the year 2000 to 2017, humanity worked together and decreased 20% of that impact. Your generation gonna have to do that. Second dimension here is photochemical ozone, which is the near ground ozone formation, like LA, like China. You see this, right? The smog. We should specify material, especially in global south, that do not do that, so they don't have that impact in the future, right? That's another dimension you have to think about. Another dimension you need to think about is the water, acidification of the water. Certain material will make the water acidify, become acid more, like CO2 dissolve into the water. Try to avoid those material that does that. Bad for our shellfish. If you still want the future generation to have shrimps to eat, crabs to eat, so maybe don't want to do that. This dimension may be one of the most interesting, is the eutrophication. Now, this is North America. You look at Mississippi Basin. Guess what happened is eutrophication. It is the nutrient, because we took away all the plants, all the trees, the soil, thinning of nitrogen. We add fertilizer in there, we add phosphate in there, and they run off to the Gulf of Mexico. 40% of your nitrogen is actually from fertilizer. There was a time US has the bison in the Midwest. We have the bison and the prairie that create this super fertile soil, but that topsoil has depleted for the most part. That's why we keep on adding more fertilizer to our soil and run off to the Gulf of Mexico. As you can see here, the red. How big is the red? Oh, by the way, the red is that what we call hypoxia zone. It's the runoff of the nitrogen create this algae bloom and killing all the marine life. The size of that is roughly the size of Massachusetts. And every year, it will create a dead zone. The dead zone, in fact, is going to be like this when you look down from the satellite. That is algae bloom and all the fertilizer we put into the ocean. Not only, now think about it. If this stuff goes into the Gulf of Mexico from the fertilizer, it also goes into our tummy, because much of our food is from the same nitrogen and phosphate from our farm. If another reason you wonder why humanity is not as healthy, well, what did we do to our food, right? What happened to your gut microbe? How come we are not the same as the Amish people? Something to think about, isn't it? So that's eutrophication. Now, this is SOM's work, is farms like that open up to the atmosphere, let the nitrogen go away. As your generation start demanding bio-based material to sequester the carbon, it's very, very important that the material came from regenerative farms like this, farms that has cover crop and not let the nitrogen go away. If we continue to specify bio-based product, not from regenerative farm, you are seeing more algae bloom, and also you are seeing that fertilizer goes more into your tummy and my tummy. Not a good place to be. It's a worldwide problem. It's not a US problem. All those red dots are the algae bloom because we have to feed 10 billion people. The worst is yet to come. So finally, in an environmental product declaration is the earth, is the resources of the earth. It could be fossil fuel-based, natural gas, fuel oil, or not fossil fuel-based, air, mineral, and all that stuff. We will try to need to minimize that. How do we do that? It goes back to circular economy, circulate everything. So that's why I want to go back to the tree I saw in Bursa, Turkey. Remember when we touch on the tree, we talk about what if buildings are like trees, it sequesters carbon, it actually clean up the atmosphere, like the environmental product declaration we went through just now. It clean up the atmosphere, the air, clean up the water, clean up the ground, and it recirculates everything. And if it can last for 600 years, it will be just beautiful. So with that, I'm gonna stop here and see if you have any questions we can talk about.
This was excellent. Thank you, Luke. You took us, you explained very well. You took us through those three factors that will impact the careers of those students graduating in May. And you mentioned carbon, health, human health, aging, and the third one, terrestrial. And it's so impressive. I mean, SOM is doing so many things, not just, thinking about buildings and how to put a building there, but the collective interdisciplinary nature you described from the beginning, from day one. And obviously the future will be more about embodied carbon dominating. And SOM, as a firm that has done very tall structures, you would describe the wind loads and all those challenges, but thinking about the embodied carbon of those high-rise towers is very interesting. And you do a lot of in-house research, study. I remember 10 years ago, you published a study together with Arab on tall timber towers.
Yep.
Long time before anybody else. And I studied this study very carefully. I was very impressed that you gave it away for free. And it was a very interesting study that you produced in-house, SOM and Arab. I remember that, or maybe 11, 12 years ago. So the density we want, you mentioned, the mini buses have a great future. So you spoke about a lot of interesting things. You will know that 2 days ago, we just reached 8 billion people on the planet, 8 billion earlier than expected. However, now population growth will slow down towards 10.4, 10.5, and mentioning how can we do buildings like a tree and a city like a forest, buildings that can be 100% recycled, bio-based materials, respecting based on the circular economy. So it's very, very interesting to have all this and to edit this video to our archive of wonderful videos from Renzo Piano, Snow Hetta, MVRDV, and so on, which we always have on YouTube, a YouTube channel where we have maybe 20 videos so far from an architect. So that will be very, very widely. We get a lot of viewers there. So are there any questions now? We are very fortunate to have Luke, one of the principals of SOM. Anybody wants to ask something? Open to questions, Bijan?
Yeah, I have a question. Thank you for your presentation. That was amazing to see it laid out in that way. I have a question about the embodied carbon. I noticed you're LEED certified, and LEED currently doesn't really take that into consideration as far as a building. Do you think that there's going to have to be a shift, or maybe a new metric where you can create and have that embodied carbon be calculated? That's my first question.
So let me deal with that first. We just met with Peter Templeton, the new USGBC CEO, yesterday. He was in our office, and that was the first thing we talk about, is this idea of whole life carbon. You probably should get familiar with that term. Now, let me also tell you one thing is, it is not siloing operational carbon and embodied carbon and say, okay, I'm going to minimize operational carbon, then I'm going to minimize embodied carbon. Those two things are tied with one, right? So you have to optimize both. Otherwise, once you silo those two things, you will never get the optimal the optimal solution. A quick example of that is, let's say if you have a very strong envelope, very passive building, very high embodied carbon, right? If you want to optimize embodied carbon, you will never do that. But if you study the whole life carbon, then the passive building will make a lot of sense, because it subsequently reduces a lot of the operational carbon. So we really need to look at this whole life carbon as one thing, not two things. Having said that, and that's what we talked to the USGBC about, is how do we look at this as one thing? Because right now they have a operational energy, right? But they really didn't address whole life carbon. So we have to change the industry, and it start with dialogues. By the way, let me also tell you another thing. Never think, we have how many people on the screen right now? 12 people. Never think 12 people is not sufficient. I tell you one example. Earlier, when President Biden became elected, there were 12 of us from different firms. I was from SOM, and there were some people from RTKL, blah, 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 like the US firms together. And then 12 of us, we said, well, what we can do to change the movement of US. And you know what we did? We decided to write a letter to the White House, 12 of us. And then that letter got signed by 150 US firms. And it was forwarded to the White House to get a 150 firm signature. And the White House asked to see us, and we went to the White House and talked to the president. Subsequently, 2021 executive order on December 8th, majority of the stuff that we wrote down to the president representing US industry was incorporated. So when you ask that question about what whole life carbon is not getting incorporated, we know that, and that's why we met with the president of USGBC. And you know what? We're going to change it. We'll find a way to change it. Do not underestimate 12 people's ability to change the world. You can change the world.
Awesome. I have a follow-up question. And I mean, obviously we live in Las Vegas, which is built off urban sprawl, you know, much like Los Angeles. And it makes me think about the bigger question of designing for change and everything you said here in America. I mean, you live here now, but it seems like there's so much more progression happening in other countries. You know, as you mentioned, China. Are we at? Is our challenge bigger because America has kind of taken the stance that we have, and there's so much open land? Everyone still wants their own house and their own yard. You know, to switch that mindset for everyone that's going to be part of this next 2 billion people. You know, a portion of that is going to be Americans. I see it as more challenging than if I was, you know, working at a firm in Hong Kong or in Europe, where it seems like more community effort for that push. Do you feel like there's a little bit of a challenge there, being an architect in America for this foreseeable future that we're going to be going through?
Yeah, it's tougher because of like what you mentioned, the American city in general are not as dense, and we like the big house, single home, and the suburb, the American dream, and all that good stuff. So it is tougher. And not only that, typical Americans, the other reason it's tougher is, you know, a typical Chinese, 40 years old Chinese, how much do they weigh? Let me tell you, it's about 160 pounds. How about a typical 40 years old American today, male?
Probably another 100 pounds, maybe.
It's about 195 to 200 pounds, 190 to 200. Right. So like
Okay.
the people in general are bigger, so they consume more, they travel around, require larger carbon footprint, and they live in bigger houses as a result, and that's larger carbon footprint. So that is a challenge. But the opportunity there is, there are so many things that once this country committed to do, we have the ability, the innovation of the people is just truly amazing in this country. I think with that together, collaboration and innovation, we can think of ways to overcome issues. Remember, one of the slides I show is that hole in the Arctic Circle, right? The ozone depletion. We, America, is one of that global effort, figure out ways to minimize the size of that ozone from, you know, by 20%, right? So together we can think of ways to take care of the issue. Yes, there will be many challenges. There's no perfect civilization. We're gonna have to figure out ways innovatively to overcome some of the challenges and create opportunities, have a new design challenge. I think that's the fun part about our profession, is we will have to come up with design solutions to overcome some of those issues.
I agree. The US can change very quickly, and we've seen this many times. You know, of course, changing values and behavior takes some time, but you know, having lived in many countries, if people get behind an idea here, they really go forward and do it. You know, more than in many other countries. And so, never allow someone telling you this cannot happen here. You know,
Yeah.
I live in the US. I love the US because, you know, all my life I've always been admiring the spirit and the drive the community in the US can unleash. when they are convinced, they get it done, they get the job done. And I have lived all over the world. I've never seen anywhere in a country this factor to be so strong. But let's, any more questions to Luke?
Oh, I would like to also emphasize one thing, design professionals are a little different. We are not like the co-official, we're not the government people that can dictate certain policy top down, right? Now, China, April 1st this year, come up with a new policy, new building 40% carbon reduction than the building 5 years ago, right? They can do that. They have this very top down sort of authority. And then you can, other changes you can make is bottom up, right? You can light a candle. But design professionals are unique. We can always design a better sandbox to inform the neighborhood kids how we can play differently, so that when the other kids walk by, they said, Mom, I want to do one of those. I want to be one of those. I want to be in that sandbox. So in that way, we change the world by creating this candle to show the way differently, right? So that's design professionals. And I think we can inform a better future through our innovation and the ability to see things differently.
This is so interesting today. Thanks, Luke. Mirelia, do you want to add something?
Yeah, I do have a question. I think Dylan, hi. Well, first of all, thank you for being here. I think Dylan kind of touched on this a little bit, but how does your collaborative process work in your firm? I know that on your website, you talk that you have many people from different backgrounds, planners, architects, and engineers. How does every day look like at your firm? Do you bring different peoples with specifications immediately, or is it as needed, and things like that? I have another question after this. But
So let me take it one at a time. So this will inform the way you want to work in the future. Let's say in the world, nobody knows everything, right? So how do you collaborate with people? Now, let me tell you how we collaborate. So me and some of the designers oftentimes is using literally the iPhone. The moment when the idea start conceptualized inside the person's brain, the designer's brain, he may text me and say, Luke, I'm thinking of a cone shape like this, and I think about that. What do you think? Then I said, well, cone shape, you may want to do, maybe make the top part larger or the lower part larger, or maybe we need some holes in the middle. And then he will text me back. So oftentimes it's like the moment you got the idea, then he start texting us. Now, there's also more formal sort of collaboration. Is in a kickoff meeting, oftentimes we get the whole team together and have a round table. Everybody has a voice to talk about what do they think about this project. But there's a more formal way. Oftentimes is this side conversation. The moment the designer had an idea, he actually texts me. We use a Slack channel, which is kind of a very simple text, and you can put some diagrams in there. And then we start shaping each other. That require a level of trust, a level of respect and all that stuff, right? I mean, you only talk to certain people, or you obviously will talk to the people you like more than the people you don't like, that sort of thing. So there's a lot of dynamics back there, but oftentimes is that deeper level of collaboration, which is more important than the more formal ones.
thank you. And my next one is a little more personal. I've asked almost every architect that we meet, what is your work-life balance? You've kind of mentioned that sleep and rest is extremely important. How do you balance all of the things in life? And has that changed over time?
That definitely changed over time. It's very personal. In general, I think you have to make your priority. I certainly have my priorities. To me, obviously, my family is the most important, for many reasons. So like at one time I was assigned to a casino in Las Vegas, actually. and the tallest casino in Las Vegas. And and I have to, like they told me, I have to go to Las Vegas for 5 years. Every Monday I have to fly out there and do that. So I make a decision to actually quit my job, so that I don't have to do that for 5 years. So, but that's personal, and that's the time when I have smaller, younger kids, right? So it does change as you go through the different phases of life. Right now, my kids are a little older, so I can afford to be a little bit more spend time. But I think you have to make your priorities, and then you work with what your priority is. And yeah, and it's not easy. It's oftentimes is, to me, it's Saturday, Sunday. But you have to make priority to set out what's important to you and work it out accordingly. And it could change with time. If your kids are small, you might do certain things, so yeah, those are not easy, no doubt.
Thank you.
Yeah, you can see why Luke is in such an important leadership position. He's able to explain very complex and complicated things very simple and clear. And that's a very strong, powerful quality if you lead a discussion or you chair a meeting and so on. I want to ask you something else, Luke. Looking at SOM, and looking at SOM for many years, for 40 years, looking what this firm is doing and thinking about, Goldberg, who was there part of at some point and then went off and did some Marina City and, SOM, the early buildings, Liver House, the invention of the curtain wall and, an incredible building legacy,
Right.
that lives on more or less within the office. How do young people, are they afraid that they are under the pressure of this huge legacy joining the firm? They think, I have to do a certain type of architecture. I have to behave in a certain way. After Lever House and John Hancock building, we can't achieve anything greater than this anymore. The holy grail of modernism. Do people feel affected by it, inspired, or maybe oppressed? Can you tell us a little bit out of your experience?
Yeah. I think the people that we treasure the most, and you should be like that, you as in the students here, you should be like that, is can think bold and make no small plan. Think big. And the leadership appreciate that. There's no walls, no boundaries. Oftentimes in my work environment, I actually listen to the young people or the junior people a lot, literally, because they know things I don't know. So I lean on them to tell me many things. So the environment is, in general, is encourage people to have no walls. Just go like where you can go, and just take the team there if you see the vision. Now, obviously, there will be guidance from the leadership to make sure you go into the right place. The history is obviously very helpful to build upon that and go to bigger and better places. But it was never become a boundary that, kind of, but more like something you build upon to get to a bigger and better place. And usually the way we work is we kind of work together as a team to get there. You probably get a sense of how we work is a lot of texting, email, water fountain conversation on what's the next big idea. And yeah, innovation is a big part of that culture. And once you think about innovation, you cannot have walls, you cannot have boundaries. You just go, right? It's like you just go. You just kind of more like a musician, when they play music, they just kind of, or like an artist, when they see this thing in a rock or that when they just kind of can hear this music and you just go there. It's kind of more like that sort of thing when you work together to create that vision or play that special music.
Right. Maybe one last question somebody might have. Anybody? Bijan?
Yeah, I wouldn't mind asking one more. I know you mentioned that there's a push to have, the building being built, recycled materials, and then at the end of the life of that building, for it to be able to be broken down. I was just wondering, with a massive firm such as SOM, your buildings are going to last a long time because you guys are very good and they're designed to stand a long time. How do you, if it's even a thought, decades, maybe 100 years from now, when one of these buildings might need to be disassembled, how do you think about that? Is that something that is even of concern, or are you just thinking about the carbon operational and embodied for the project, like for way long term, past our lifetimes? Is there a thought as far as disassembling these buildings later in 100 years and being able to reuse these materials?
Yeah, so we are scratching the surface on that. But to your point earlier about how a building, now, most of the life cycle analysis that you will encounter when you first come into the industry, right now they assume a building lasts for 60 years. The life cycle analysis assume buildings last for 60 years. But having said that, since we do a lot of tall buildings, any buildings taller than 200 meters, right? There are 1,628 buildings taller than 200 meters, like back to a couple years ago. There was only one building that taken down. So to your point, yeah, once you're taller than 200 meters, chances are it may stay longer than 60 years, maybe much longer. Burj Khalifa, the building we did, when we designed it for 100 years, but the structural engineer will tell you, Bill Baker will tell you, it could probably last a lot longer, maybe even to infinity, as long as you don't, you just keep using it. The structure is not going to fall down, right? So like, you cannot really anticipate what the future holds once it's beyond like certain time. In fact, actually, most of the time you cannot really predict the future. So all you can anticipate is maybe use material that are more friendly. Now we are start really just looking into that, exploring that. You can look at urban sequoia in our website. You will see a building type that is designed for that. And what do we vision like a potential future building can be, and how do we recycle this material? A lot has to do with use of bio-based material so that they can be recycled. And the other part has to do with a lot of modular things so they can be taken apart to do other things. So, but that is one concept we are developing on this kind of recycle building, or maybe building that can be reused in the urban sequoia. And also we're doing a research with National Renewable Energy Lab and Carbon Leadership Forum, informing end of life of the current building material, how we're going to use them. So that is in the works. So we are still experimenting that, but we do have a vision of what that can be like in urban sequoia.
Awesome. Yeah, I can only imagine how, just in 50 years, 60 years, we've recognized different materials and different approaches. So it's definitely a challenge to try to plan for what we might be using in 60 years from now.
Yeah.
Too.
They have a in the Chicago World Fair, they asked a question of like 15 experts. Like this is way back in history, right? They asked like a bunch of experts, what do you think the future will be like, right? And then there was one person got it right. After a long period of time, they realized that one person was right. What did that person say, and how come he got it right?
Richard Buckminster Fuller. No, even before him. No, what did he say?
Yeah, the only person got it right was, I do not know what the future holds. And he got it right. He said, I cannot predict the future. Everybody who predict the future, what it's like, got it wrong, except the one who said, I really don't know what the future will be like. He got it right, because it was completely different than what was. So the point there is, it's really difficult to predict the future, but there are omens of the days. Like today's world, we know that if you use bio-based material and modular panel-like structure, is more likely to be recycled in the future. So that's where we are thinking about right now.
That's great stuff, because Bijan is just working on his final design project using modular kit of parts, system thinking. So very, very good. So you should go bio-based, recyclable, 100% Bijan.
From regenerative farm.
Yeah, exactly. Yes. So maybe another last question is, look, there are a lot of new visions for the future city around, I mean, SOM might have contributed also one, but, there are from Stefano Buri to Morphosis, the line in Neom in Saudi Arabia, that long 100-mile long line in the desert, to all kind of ideas how cities could be evolved and built in the future. Foster has a project or several projects, big, and so on. So the question is, there's a lot of greenwashing, and those cities are planned in fragile, vulnerable rainforests, to cut down the rainforest to build a new city. Obviously that's greenwashing. That's not sustainable at all. And so any thoughts about that? I mean, obviously the location and the densification, urban infill alone will not be enough to provide all the spaces we need, but how much percentage in future we should have urban infill? Some people say at least 50 or 80%, there are different views on that. And how can we avoid those greenwashing projects that, look very nice on paper, but actually as soon as you drill deeper, they don't make any sense. Any thoughts on that?
Yeah, those are the tough ones. And there are definitely many cities, for example, in Chicago, you can easily double the density, infill the urban blocks to get double the density. And as a result, your transportation carbon is much lower. And the density is still not that high, even if you do that. So there are a lot of opportunities like that. But the urban area compared to farming is actually relatively small, right? Our bigger issue, as you saw in the world map today, is actually how do you feed 10 billion people? And if we continue to chop down trees and build more cornfield, that's probably not a very good solution. So to take care of food, so from the urban sequoia, you see our solution is actually start using the building as a way to accommodate people, but also start generating food farm, regenerative farms. So the issue of farming could be a big part of that solution too. In terms of the greenwashing, I think it's exactly like that. Part of that is, what do you want to do, right? Some people are more like an artist when they work. They create art pieces. Other people, they are more informed by science and create a form informed by science and what actually the facts behind it. So I think there are room for either one. And, so you have to decide, like, what do we want to do, right? So like we tend, as you can see in the presentation today, we tend to model a lot of things and use a lot of the science behind it to inform some of our design. That's what we prefer to do. Oftentimes there are answers we still don't know, even if we try. But that's some dimension you have to decide what's in the entire spectrum, how do you want to fit in, right? So yeah.
I think that's a nice way to end this presentation and discussion today. And you gave us a lot of food for thought, and it will become part of our video archive where a lot of people will see it in future. And it's been a tremendous honor and pleasure to have you as our lecturer today, Luke, and wonderful. We wish you everybody a wonderful Thanksgiving. I know you're doing the turkey thing. So we spoke earlier a little bit about, and again, thank you from the whole group and from UNLV School of Architecture for making time and inspire us, but also critical reflection on our profession at a timely point now today, where we have 12 students, 10 students that will go out there and join the profession in a few months, very soon. And I think you inspire them very well in a new direction. Okay, so thank you, everybody. Thanks a lot, Luke. And we say bye-bye to Luke now.
Thank you.
And reconvene in 10 minutes to... Yes, Mirelia, or somebody wants to say something? No? Maybe mistake. Okay, the microphone was briefly on. So thank you very much, Luke. All the best. Have a wonderful time over Thanksgiving, and I look forward to catch up with you very soon again. All the
Take
best.
care. Happy
Thank you.
Thanksgiving to you all. Bye.
Bye-bye.